Hello, everyone. I'm Martin Bureau. I'm Vice President Innovation at Sanexen. We'll be talking today about the seismic resiliency evaluation of a structural cured-in-place pipeliner for water mains. Before starting, I'd like to acknowledge the contribution of my co-author, who did most of the work, someone who needs no introduction, Thomas Dennis O'Rourke, who will be presenting in this session later on. I would have very much liked to be with you in presence. Unfortunately, it's not possible. I look forward to meeting some of you in the future. Definitely, we look forward to meeting you in person in the near future. The session that we're about to present today is the result of a multi-partner project that aimed at the demonstration of a structural cured-in-place pipe technology, Altra proven solutions, for water main replacement. It was launched by Sanexen and now is called Altra Solutions. It was developed with the support of Sustainable Development Technology Canada, which is a foundation in Canada for science that funds technology demonstration. And of course, in collaboration with Cornell University and the laboratory of Professor O'Rourke. We did that work in collaboration with Los Angeles Department of Water and Power, San Francisco Public Utility Commission, the East Bay Municipal Utility District, and the city of Dollard-des-Ormeaux near Montreal, a small suburban community on the island of Montreal. So what's the common thread between hosing off your driveway, watering your lawn, and washing your car, spending a lot of water? They all will cause you a fine soon in California because of the drought and the shortage in water. And that creates quite unique situations with articles like this one from the Bay Area News Group. Who saved the most water? Is it the North Coast, the South Coast? I'm not here to comment on that. But it's really a stigma or a sign of how important water conservation and water quality has become. And as a result, cities have come up with clear environmental, social, and governance targets, ESG targets. San Francisco has extremely ambitious goals of reducing emissions by 40% in 3 years. Los Angeles, 55% in 3 years. And other cities have very, very demanding challenges as well, targets as well. I'm not going to go through all of them, but San Jose, Oakland, and whatnot. And there's also resiliency and conservation plans. San Francisco and SFPUC have a disaster preparedness plan for their water infrastructure and their emergency firefighting water systems. Los Angeles has a similar system. San Diego is looking at sea level rise. Sacramento has extremely challenging goals as well. And San Jose wants to replace 1% of its network every year, the water main network, of course. Not to talk about Oakland and East EBMUD, who has a target of 70 million gallons per day of water conservation soon. So that begs the question of how are we going to address the aging water infrastructure issues without the impact? So how will we change 1% of water main per year and reach all those environmental goals, emission goals and whatnot? And I took two pictures that tells it all. You've got on one hand, open trench replacement, a picture taken a few summers back in Montreal. You see those stores, they're all closed. They all went bankrupt. This is a job that took almost 3 summers to do, and all those businesses have closed, or almost all of them, like 80%, okay? And I'm not talking about the local communities, the house. How do you access your home when you live there? It's very important. When it's necessary, you ought to do it. But when it's not, why would you do that? You look at Trenchless CuredinPlace pipe replacement job, in this case, a California job that we did on the coast 2 years back. You see, 3 years back. You see the job, this is one of our trucks, and you see the other access pit. There was almost no footprint, no impact on the roads. People could access their homes. So that's what trenchless replacement offers. So for those who are not familiar with trenchless technologies, here is a few of the steps that you need to go through for a job. So first of all, you access the pipe through pits. Then you locate the pipes and clean it with high pressure jetting equipment. Then you inspect it using closed circuit TV, and then you map all service connections, which you then plug to make sure that they won't be affected or clogged during the installation. And you use robotics because you don't want to dig each of those lines, each of those entries. And then you install the product. It's a fabric that you install into the pipe. It's wet out with resin, and then we use the water to blow it and conform it onto the hose pipe. And then hot water for curing. It becomes hard, it becomes structural. And then you reinstate each service, again with our robotics, and you return to service after inspection and chlorination. And of course, pressure testing. Now, using a technology like that, instead of open cut or conventional replacement, you save a lot of greenhouse gas emissions. The impacts are tremendous. This is a third-party analysis done by Sustainable Development Technology, comparing greenhouse gas emissions in CO2 emissions for conventional replacement and structural trenchless rehabilitation technology. And by doing so, you go from 400 million tons of CO2 equivalent per miles down to 66 using our technologies, 84% lower. If you translate it into 68 miles per year, which is a target that a city large like Los Angeles could have, this technology, our technology, could help save 23 kiloton per year of greenhouse gas emissions, 65 tons of other types of atmospheric pollutions like VOCs, NOx, and SOx, and 2.2 million gallons of fuels. Huge impact environmentally speaking. But there's also structural impacts or economical impact. Delors Desormeaux, who participated to this study, shared some numbers with us. This is the number of water main breaks as of through the years since 2000 when they started their Cured-in-Place pipe rehabilitation program. So far, they've replaced almost 50% of their 124 miles of network. And by doing so, they reduced their number of water main breaks by 80%, from 80 to, let's say, 20 or 15. Huge impact. And all those water mains now, all those water main breaks now occur in non-rehabilitated sections that were not lined with our product. So if you translate that into the same goal of 68 miles per year, that's 1.5 million cubic yards of drinking water leaks based on 7.5% non-revenue water. That's huge water savings every year. And finally, installation statistics. This is the social and the economical benefits. A single crew in one run could install up to 800 feet of products, change and renew 800 feet of water mains. That's 1,500 feet per day per crew replaced. Nothing beats that. And so far, using our technology, we've replaced close to 1,400 miles of water mains since 2000. We did 70 miles last year, despite COVID. And because you're not opening the street, you avoid the dig, the landfill, and the backfill. For an average of 16 tons of soil preserved per mile. With the same goal of 68 miles per year, this is 1.1 million tons of soil preserved or landfill avoided. That's 55,000 fewer trucks per year that are not going around in our downtown areas where this technology applies the best. So that's very tangible and very clear reduction in disruption of a technology like that can offer to cities, businesses, and homes and residents. Now, a word about the material. It's a structural, cured-in-place pipe liner. It's called Altra 10X. It's a composite material, aerospace grade, very similar to aerospace grade material. It's based on a woven polyester fiber and a glass fiber jacket. It has an internal watertight polymeric membrane. That's specially designed for potable water contact for 100 years. And it has a thermosetting resin, an epoxy, which upon curing gives it its structural characteristics. We're able to accommodate from 4-inch to 24-inch, and it's generally designed for 100 psi pressure, operation pressure or more, depending on the case. And it complies with all standards required in the States. And you see the structure on the slide here of the urethane membrane, the inside jacket, the resin that wets it out, and the outside jacket. With our product and our company, you get a unique integrated solution. We're the only company of our kind that is vertically integrated, where we own the product design, all the IP. We do the manufacturing ourselves in our plants from the raw materials, from the individual fibers, and we install the product throughout North America. And by doing those three activities, we gain an expertise that is unmatched in the industry. Our design is based on a circular weaving that is seamless. You see a circular loom here. There's no suture, no assembly, no seams, and that provides extreme reliability of our product and resiliency. It's a strong composite material, and we, as I said, have proprietary resin formulation and production. Now, using materials like that are related to structural class 4 lining as per the American Water Works Association nomenclature, we know that we can increase pressure capacity and flow rate. You see a pipe before it's cleaned and then after it's lined with our product. It's obvious that the flow rate will be amazingly improved. It provides corrosion resistance because this is not prone to any type of corrosion. And it restores structural capacity. It will extend the life expectancy by at least 50 years. We're working on the demonstration for 100 years. And it's going to reduce water main breaks, as I've shown earlier. But the question we ask ourselves, and that people in California have asked, is, can our material provide the resiliency to water mains against very severe soil movement, like earthquakes, for example? And that's what we tried to address in this program. And where better could we have gone than Cornell University? This university and the Geotechnical Lifeline Large-Scale Test Laboratory needs no introduction. It's the go-to place for testing against earthquake resiliency lifelines, and that's what we did at TharmaWorks lab. And he'll be presenting the whole program and all the results that we obtained with our product. Now, just an introductory comment. So this is the fault rupture test that we did at the split basin facility. You've probably seen a picture like that. You see the basin. The bottom part of that picture, that basin, actually moves under the action of 4 actuators. And that's moved to shear a product that would be embedded in that basin, a pipe, for instance. And that's what Tom will be presenting us about later on. Now, you're going to see a movie here. It's the recording of the test that we did on our product. You see a top view of the basin. And as it's going to play, you're going to see both sides of that basin aligning as the basin moves and the product is sheared. And you'll see that it goes to full extension, both sides aligning completely, because the test was not stopped. Why was it not stopped? Because there was no breaks, no leaks. The product survived the full test. That's actually disappointing for those who designed it, because it's meant to break pipes, not to let pipes survive. So that's very interesting. And we're very proud of the results we obtained. Tom is going to talk extensively about the results. Just a word. You see the pipe once it was unburied. You see how sheared it was. You see how intense the deformation was. The elongation was tremendous, almost 40 inches in length. Actually 6% of elongation that was permanent on the pipe. Obviously, all the pipe joint failed, but it was bridged by our product and therefore did not fail. You see the type of joint opening and joint rotation that we got during the test. Very, very important, very intense. Yet, no failure. And the conclusion was that it would have been able to survive the big earthquake that we unfortunately expect perhaps in the future in California. And in particular, would have survived the 1906 San Francisco earthquake. This is superior seismic resiliency that was confirmed by Tom's team at Cornell. Now, why did it do so well? And I wanted to emphasize on this. And let's go back to fundamentals. Resiliency in material science is the measure of how systems absorb deformation without failing. So put very simply, if you look at the tensile curve, so a stress-strain curve, and this is one, it's the area under the curve. The area under the curve is actually a measure of energy, and the more you get, the more resiliency you get. And you look at all other type of trenchless technologies that are used, that are based on felts or even unreinforced plastics, and of course, they don't have much resiliency. As you can see here, the area under the curve is very small, and those are actually real curves. So this is very small. And our product, since it's a structural, extremely resilient composite, it absorbs a lot of energy before breaking. And as a result, it led to larger elongation, larger joint opening, larger rotation or bending in comparison with any other trenchless technology product, or even any other resilient pipe systems, including ductile iron pipe. We're very proud of that. Now, using a product like that, you get from a trenchless technologies that have very little impact on the environment and very little disruption, traffics and local businesses. You've got earthquake resiliency. You've got 100 years of duration of your product. You have a structural composite that will not break, that will not corrode, and we help you reach your ESG target and your water conservation and resiliency target without adding one more pipe in the ground. With that, I hope that the presentation of my collaborators, Katie Miller from SFPUC, David Katsev from EBMUD, and finally Tom O'Rourke, which will dig into the results of our program, will convince you that this is a great technology that can help you reach your targets. Thank you very much for your attention. And before finishing, I'd like to say hello to all those friends that witnessed the test at Cornell, Tom and his team, and people from LA, SFPUC, and EBMUD. That was a great time. Thank you very much. I'm Martin Bureau, Vice President Innovation at CNXN, talking to you about our CuredinPlace pipe product, Altra. Thank you. And I'll be happy to answer any questions later on. Bye-bye.